Hey Algebra 2, in this video we're going to be continuing on with section 7.2 and we're going to be focusing on reference angles. So in the last video we talked about graphing in standard position, or our last lesson. So reference angles are really important when graphing in standard position. So let's talk about what a reference angle is. Alright, a reference angle is the angle made between the x-axis, and the terminal ray. So the angle made between the x-axis and the terminal ray is the reference angle. It must be between either 0 and pi over 2, if we're in radians, or 0 and 90 degrees, I should say 0 degrees and 90 degrees if we're in degrees. And because it's always between 0 and pi over 2 and 0 degrees and 90 degrees, this next thing might be obvious, but sometimes people mess this up. It is always positive. Okay, all right, so let's do an example of determining a reference angle. All right. So we're going to sketch each angle in standard position and label the reference angle. Okay. So for the first example, let's do 311 degrees. We'll start with degrees. Okay, so let's make a sketch of a coordinate plane. Since we're in degrees, I'm going to label our axis angles, right? So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So if we want to graph 311 degrees in standard position, it's going to be somewhere over here. Alright, it's a positive angle. So remember, we start on the initial side and have an arrow going in a positive direction toward the terminal side. And then we label this as 311 degrees. Alright, now the reference angle. So the reference angle is the angle made between the x-axis and the terminal side. So that's the distance between the x-axis and the terminal side. And it's always positive, so we're going to draw it in a positive direction. And then if this is 311 degrees and this is 360, then we can just take 360 and subtract 311 to get the measure of the reference angle. So 360 minus 311 is 49 degrees. So that means the reference angle here, which we can label is 49 degrees. So it follows the fact that it needs to be between 0 and 90, and we must draw it in a positive direction because they're always positive. Alright, let's do a couple in radians for practice. Alright, let's do 7 pi over 6. Alright, so because I'm working with radians, I'm going to do the same thing I did in the first example, but I'm going to label everything in radians. We don't want to convert, we want to get used to radians. Okay, so that means this is 0 pi, right? Pi over 2, pi, 3 pi over 2, and 2 pi. So if I want to graph 7 pi over 6, one tip is to rewrite some of these angles with the denominator of 6. So I like to always start with pi. So this would be 6 pi over 6, which means 7 pi over 6 is going to be pretty close by. So 7 pi over 6 is going to be a positive angle. I'm going to start on the initial side, open towards the terminal side, and label this as 7 pi over 6. Now, this is where students tend to mess up. Our reference angles, remember, are always positive, so it's going to be from the x-axis to the terminal side, but in a positive direction. And then we take 7 pi over 6, we'll take the bigger angle and subtract the smaller of 6 pi over 6. So that means our reference angle is pi over 6. Alright, so there's two examples for you. One's in degrees and one is in radians. Remember, you always need to be positive, and it's always the angle between the x-axis and the terminal ray.